This is weird. You can change the configuring. I wanted to order the little like Garth Brooks style thing. Oh no, really? It's gonna record me.
No, it's live.
Phil asked where the screen was.
Stream that.
Hi, Phil.
I wasn't planning on this. No pressure. Is someone really watching this?
No.
It's recording me. Now we have all this awkward talk. So at this point, whoever started watching this definitely stopped right now. Okay, so let's jump into this, the topic for tonight, which I gave kind of maybe an overly fascinating word because microservices is this cool thing that people talk about in blogs and stuff. And you know, we do microservices. This is microservices with OSGI. So a lot of you guys may be using microservices now and not realizing it. OSGI's definition of microservices are services that live inside the JVM and only inside the JVM. And so as we were setting up for this, we were talking about it, that it's different than other microservices that you might think about where you might run some little web service that a RESTful web service or something that takes and gives back JSON. You can certainly host that in OSGI as well, but the context of this is things that are running as very tiny services inside the JVM that can be composed together to create a larger, externally accessible service, a full application, etc. So I wanted to use the project that we work on as context because I think that it actually gives us a really nice use case for why this technology is helpful. The reason that we use it in the first place is that the clients that we have wanted to be able to change their systems very, very easily. They came to us with requests like, I want to be able to add new behaviors just to the system, just like I add apps to my phone. And the system for our guests is, you could think of it as a search engine plus an ESB. So it's a search engine, that part's pretty easy to understand. And the ESB part is that it can plug into all different sorts of data, and it can expose interfaces via all sorts of different services on the front end. So it's like a really, really pluggable search engine. And it's available as open source on the internet. It's on GitHub. We work with an organization called the CODICE Foundation, C-O-D-I-C-E. And that organization, which we were a part of, was really built to help projects transition from government open source to full, free and open source software. Believe it or not, there's a lot of software that's paid for by taxpayer dollars, and the contractors, they think it's good enough to make it freely available within the government. And we like to go a step further than that and say, well, why don't you make it available to everyone, including the taxpayers who basically funded the thing. But since our project has gone open source, that's actually helped us out immensely because now people in other countries and other companies all over the place are seeing it, learning about it, adopting it. They could have had access to it before, they just didn't know about it. So a little bit of a pitch there for the wonders of open source. But back to DDF. So DDF, it works a lot like a framework in that it has these core capabilities that are then extended by particular applications of it. So different clients will use it in different ways, and they typically don't just use it out of the box. They take it, they add new things to it, they add new services, they use all this OSGI goodness to make it do new things, and then they package it all up and typically give it a new name. So we have all these other products for different clients that build on top of this common framework. So the framework has to be extensible. It has to support pluggability, and that's where all these microservices come into play. And so you can see here some things that we do. I kind of talked about the first party part that we do. We are the framework. There's second party stuff, which is somebody who takes this and is going to run it on their own. But then there's also third party capabilities that aren't done by us. They aren't done by the person using the software. They're done by some third party that can actually build an app that somebody can then go and drop in the system. Okay, so starting with the basics here. Well, one of the reasons that I like OSGI, and you guys may wonder during our interview process why we talk so much about object-oriented design, is that OSGI is really based around the fundamentals of OO. So these key points like the separations of interfaces and implementations. These microservices, the interfaces to the microservice is actually an interface to a class. So the service is the object, and the interface is not a web service interface, it's a Java interface. So understanding OO and building your systems in such a way that the interfaces are very well thought out, very much future-proof is very important, because that's the layer of abstraction that your clients are going to see. And you want to keep all of your implementation details on the other side of that interface, on the implementation side. So we used the three key aspects of object-oriented design all the time. So polymorphism, so you're able to treat different implementations of the same interface really as the same thing. So in the example of our search engine, we have a pluggable backend that can send data to a relational database or to a NoSQL database, whatever. But all the other components talk to that backend through this same exact Java interface. Inheritance, that is what we use. It's somewhat dangerous. It's gotten us into trouble sometimes, but being able to understand how to use that wisely in an OO context is very important, knowing when to use it and knowing when not to use it. But we have some examples of things like abstract classes that we then extend in places where we need to. I'm sure you've seen that. And building microservices in OSGI, you're also going to want to understand encapsulation. I kind of already hit on that a little bit with hiding the implementation inside the interface. The little bullet point here is my own little pet peeve. If you write code that has like something util or something helper, if I see said code, I'll probably ask you about 20 questions about it because it's kind of an anti-pattern in my mind. And I hit on the last bullet there that OSGI is definitely the cornerstone of what we do. Okay, so design patterns end up being really helpful as just a fundamental part of OO, and they're also really helpful when it comes to OSGI and creating these services. So what you see here are examples of design patterns that we use inside of our system. So there are some service implementations where there's really only one, and they're one singleton instance, and so like the guts of our system is this thing called the catalog framework. That's what all of the clients inside the JVM, for the most part, they're trying to find an instance of this service, this microservice, if you will, called catalog framework, and then it does. They issue requests to it, and it does all the hard work inside of there. Let's see. There's. I mean, I can go through the list here, but what it really comes down to is that anywhere in our system where we felt that there was a need for ourselves or for third parties to be able to add new behaviors to the system, we created these abstraction points, and we created them as Java interfaces. So the way that the system works is that within OSGI, and we'll talk about how this all happens, you create an implementation of a given interface of this new behavior that you want to add. Like, I want a behavior to get fired at this point inside the system. So there's an interface for that, and it says, hey, if you create a service that implements this interface and you publish it out to the service registry, all of the other services in that service registry can find you and they will invoke you. And that all happens typically through dependency injection, which is the later portion of this presentation. Okay, so this slide is, it's important to know Java, which seems really obvious, but it's actually important to know the real meaning behind all the things that you're doing in Java, the right way to do things, how to do Java the right way. I'm sure you've all seen Java done the wrong way. We've seen the single file that's 3,000 lines long, the single method that's 1,500 lines long. There's a lot of people that will write procedural code in Java, and that's really ugly. So understanding that Java is an O language is really important, and we like this book called Effective Java. If you haven't seen it, maybe we should have like a company copy that we can pass around. Okay, so finally, OSGI. So about, gosh, 5 to 10 years ago, 10 years ago was sort of the start of people talking about SOA. SOA. And Richard wore his original WebLogic shirt the other day, one of the pioneers of SOA. There was this vision that there would be these magical directories, UDDI. I don't even know what that stands for, Universal Discovery something. But basically, clients would be able to discover web services in a registry, and then they would be able to seamlessly connect to them and use them. And it was basically XML everywhere. Just SOAP interfaces, XML. We know of government programs, very, very large government programs that went wild with SOA. And they decomposed everything in their system to be a web service, a SOAP web service. The UDDI part, because of the work that we do in the government where all of the interfaces are so tightly controlled. So what I mean by that is that all the firewalls are fully locked down, and you have to actually say, I need this IP address to be able to talk to that IP address on this port for an admin to go and open that up for you. So this idea that it would be this wild west of this magical registry where people would push service instances and you would just discover them and connect up to them, that part just never happened at all. But that didn't stop people from creating all this litany of SOAP web services and trying to build their whole systems around them. So anybody who plays with, who has done this before, you know that you take serious performance impacts with all of the marshalling and unmarshalling of everything into and out of XML. And if you are receiving a call from the outside, that's one thing, but then turning around and issuing those calls internally, sometimes hundreds of times in order to fulfill your one original request, is just a recipe for disaster. And there were, I think we can safely say, like tens, if not hundreds of millions of dollars of spending on systems like that before people realize that they fundamentally don't work. Okay, so the thing is that the non-technical people, the people who were making these $100 million decisions, they loved the idea of it. It was great. There's all this abstraction. Some new person can come in and build a service. It sold on paper really, really well. Fortunately, I didn't find out that it didn't really work until much later. But all those sales points that they liked, those are really all the sales points of OSGI. It's just that instead of doing this throughout your entire enterprise and machine to machine, it's all of that on a much smaller scale inside a single JVM that you get all of that goodness. And so that's why we're talking about microservices versus web services. So by now you may have read this whole slide. The services are allowed to come and go. You've seen probably it connects to people here that you can install things, uninstall things. The services, you can't necessarily count on them being there. There will be different services at any given time in the container, and that's one of the things that you have to keep up with. But there are a lot of things that the OSGI framework itself gives you out of the box. And some of these take a while to understand because of their simplicity, believe it or not. They're deceptively simple, and so walking through these would be good to do if we have time. We're going to try to keep you guys out of here by 7. Things like being able to do configuration in a common way, logging in a common way, hosting HTTP services, servlets, things like that. Meta type is something that adds human readable descriptive information to your configuration. And it's worth noting that that is separate from the configuration itself. There's a lot of decoupling here. Passing events around, service interfaces for that. These are all things that are either part of the OSGI framework or part of the compendium. Nice of you to join us, Mr. Wire. Sorry for working. Do you want to introduce yourself and tell us something that people don't know about you? No. You suck. And that's recorded now for all time. It's going to have millions of hits. Okay, so there's a lot of good stuff in the OSGI spec. If you have time, definitely go check it out. If we had time, I would pull up these links, but we really don't. The first one is to the Java doc, and the second one is to the PDF. One of the best things that you can do to learn OSGI is to go and read the actual specification. This is a specification, and there are multiple implementations of it. The most popular ones are Apache Felix as an OSGI container, and then Eclipse Equinox. So those are both, they don't really share any code between them. They both implement the same specification. So if you're wondering what the heck is supposed to be going on, go read the PDF. It's surprisingly easy to understand. And sometimes you may call out the underlying framework for not doing something the right way. We've seen it happen before. Okay, so OSGI is awesome. And the next slide is don't use OSGI. So the real OSGI level stuff is all Java interfaces. And I mentioned Java doc, and it's all there and you can use it. However, all of these services and the dynamic nature of them, how I mentioned that they can come and go at any time. If you write to OSGI directly, and you don't know what you're doing, you can get yourself in a world of hurt. So thankfully, there are a lot of frameworks that have been built on top of OSGI to avoid all of those problems for you. So you can instead work in a world where you're much more comfortable, say just plain old Java objects, and then have these other frameworks, primarily dependency injection frameworks, wire together all of your POJOs with the magic of OSGI under the hood. We ran across a case today, actually, where somebody was doing OSGI things directly in their code that the dependency injection framework could do all by itself. So the second bullet point is important. You really want to avoid, or just be very, very aware when you use OSGI directly. Because back to the OO HIF earlier, these things really should be domain objects, object-oriented, and you shouldn't necessarily pollute them with the runtime that they are running in the container. Okay, so choices for dependency injection. The first one is the one that we use the most. It's part of the specification. It's called Blueprint. It is primarily done by the use of XML descriptors. So you're able to wire together all of your POJOs by writing some XML that says create this, inject it there. And if we have time, I want to sort of walk through quickly a presentation on Blueprint. At the time that I wrote these slides, annotations were coming soon. I don't think that those are available now. So one of the things that people don't like is the XML side of Blueprint. They'd rather have type safety and actually have the dependency declarations and all that in the Java code. So you can do that by annotations. We don't use it too much, but maybe we should look at it more. These slides are a little bit old, but at the time we used Apache Aries 0.3.1. I know we're on 1.0 something now. They just released a new version that includes an updated Blueprint, which we're kind of excited about because it will fix a bunch of the problems that we have. These are two of the best resources to learn Blueprint. One is by a guy named Guillaume, who used to work for Fuse, now works for Red Hat. Good guy, we met him at Apache Con, and he put together a nice presentation. And then the second one, believe it or not, is from IBM. IBM WebSphere uses, it uses OSGI under the hood. And so they have some really cool developer docs out there. While I'm talking about it, we may as well mention other things that use OSGI under the hood. The Eclipse IDE, All of the Atlassian tools. So if you're making plugins for Jira or Confluence, they're all OSGI for their plugin architecture. Drawing a blank. There's a lot of them out there. A lot of tools that are doing plugin type things in Java. OSGI is the natural place where you end up. And basically, that's why we ended up there. So Blueprint's cool. Blueprint's history is that it actually came from a project from Spring Source called Spring DM, Spring Dynamic Modules. So most of you guys have probably dealt with Spring. Spring is a dependency injection framework that it is not dynamic. So your Spring descriptors are run at startup, and then if any of your objects go away, or if anything happens in your system, the whole thing just blows up. So they made this newer version of it where they could have the dynamic qualities that they were looking for via OSGI. So objects and dependencies could come and go as you needed them to, as you install plugins, as you remove plugins, as you reconfigure things, etc. And they called that Spring Dynamic Modules. So they ended up donating that spec to the OSGI Alliance, and it became the basis for Blueprint. That's why you see such similarity between Blueprint and Spring. If you look for the people that work on DDF, you still see a lot of Spring in our code, and that's because of this nasty bug with managed service factories in Blueprint, that anything that uses a managed service factory, we have to keep it in Spring. So if you don't know what a managed service factory is, it's a tool where you can kind of create a prototype for an object, and then people, an administrator, could go in and click plus in the console, and they can add new instances of that type from the factory. So it has a configuration with it. Somebody can say, I want to make a new widget, whatever. Okay, hit plus, add in some configuration. The dependency injection framework in the background instantiates that object. Since we're talking about microservices, it publishes that service out to the service registry. All the other components can see it, etc. It's pretty cool that a non-technical user can make use of all of these services. Okay, there's other DI frameworks as well. One that's included with the OSGI specification, but kind of typically lives at the Java level, is declarative services. We've been wanting to look more into that for a really long time because a lot of the guys on the OSGI message board, if anybody's is subscribed to that, it's another really good resource. They will often talk almost exclusively about declarative services, or DS, rather than Blueprint. And recently, the Carafe guys, which Carafe is the OSGI distribution that we use. Think of OSGI like the Linux kernel, and Carafe like Red Hat Linux as the distribution. So the Carafe guys, they eliminated any dependency on Blueprint, and they just did declarative services at their core piece. They wanted their core distribution to be as small as possible. But there's other ones too. There's one called iPojo that has some neat features, and Keyberry for Google Juice, which it exists. I don't know if very many people use it. So the last one there is for people, especially people that are using DDF that don't work for Connexa. They could bring their, well, I would recommend avoiding other ones, but if they must, they could bring their own container and use whatever DI they want. We mentioned that Eclipse runs on OSGI. At the time, or at some time ago, almost everybody that worked on these projects used Eclipse. Now just about everybody uses IntelliJ. Is there anybody? Do we have any holdouts? Figs uses Eclipse.
Figs is very stubborn. I'm going to try to use Epic, so.
Yeah, tell me how that works.
I tried that when I started here. I don't recommend it.
Did it start?
It started and then it died trying to index our projects.
One of the government software engineers in Georgia still uses NetBeans, and he did all of his OSGI development in it. It's possible. Okay, so lots of test frameworks exist, and the good news is that a lot of it works with OSGI. A lot of the tools that you see out there, Java tools, nowadays they're making OSGI distributions of their jars that are aware of all of these services, which is pretty cool. There's one specifically, since we're talking about test, things like Mockito PAX exam for doing end-to-end system integration testing. Those are all good things. OSGI is well integrated with all your build tools. So we happen to build with Maven. There's all sorts of tooling for that. Good stuff. Okay, and standard sources of information that you probably use on a daily basis. Certainly, Google is your friend. Stack Overflow, I'm sure you guys are looking at that all the time. The other ones I would want to point out is SlideShare. So you find people that have given presentations far better than this one, and you can definitely make use of that. And then again, I'd give another plug for the OSGI specification itself. Go and read the PDF. I have it on my phone in offline mode so I can look through it even when I'm on an airplane. Okay, so that's the end of that portion of the presentation. Now, the next portion will be me blatantly stealing content from the guy I mentioned earlier. Well, I met in real life, so I think that gives me the right to do this. Okay, so Guillaume, he's a good guy. You see his name all over a ton of Apache projects that are related to ESB type stuff. Service Mix, Felix, Carafe, and then things that are on the JBoss, Red Hat, Fuse, whatever they call this conglomeration now. Things like Fabricate, which originally started like this Fuse fabric. There's a bunch of cool stuff that Red Hat has built on top of all of these projects, which are open source, but sadly have not been donated back to Apache Software Foundation. So they're copyright Red Hat with an Apache license, which isn't necessarily as great as something that's copyright Apache. Okay, so some of the things that we want to talk more about. So Blueprint, I mean, are all of you guys, is there anybody who hasn't worked with Blueprint yet in the work that they've done? Okay, so a couple of you guys have never done this, so that's good. This makes it more worthwhile. Oh, cool. The Zoom thing even works. Presentation mode. So when you look at Blueprint, it is XML, like I said, and this is sort of fundamental OSGI Blueprint in one little snippet. Bean is where you're actually instantiating your class. So I'm going to start from the inside here. So your class, this class, user_info, it's instantiated. You can pass in an argument. It'll interpret that this is a string. So it's going to, this is a constructor arg, so it's going to just call it's going to look, it being the dependency injection framework, is going to look for a single argument constructor with a string on user_info. It's going to instantiate that, and then it's going to publish it out to the OSGI service registry under the interface of OSGI DevCon user. And at that point, all of the other services that are in the OSGI service registry can find instances of user and start using it, using this object, user_info, through that interface, and only through that interface. They have absolutely no way to find out what the underlying implementation is easily, unless they do nasty Java things, which is why I said stick to pure Java. So that's really the guts of it. In Blueprint, the bottom portion here is what that looks like in OSGI, or pardon me, in Java. So this is the part that you really want to avoid, because this is where you can get into all sorts of problems. Since I'm thinking of it now, I want to mention one of the main differences between Blueprint and the other dependency injection frameworks, and that is that Blueprint makes service proxies on all of your services for any of your dependency injection. This is kind of hard to explain, but because of that dynamic nature that I mentioned, that services can appear and disappear at any time, what Blueprint does to satisfy your code's dependency is it gives you a Blueprint proxy, so that your code always hangs on to that Blueprint proxy, and then behind the scenes, as things come and go, it will then replace and plumb in whatever those actual dependencies are behind the scenes. So you will never get a null pointer exception once Blueprint has done the initial injection of that dependency. If that makes sense. Some of the other dependency injection frameworks will not give you a proxy object. They will just give you an object and then take it away, and you will get null pointer exceptions.
So what does Blueprint
do that. So if the proxy object that's fine that's there, and there's no implementation behind it, so looking at evil.
It goes into like a service unavailable exception. You get some kind of runtime exception. It will actually block though for some configurable time while it's waiting for that service to come back. So you may have seen like grace period when things are starting up. It's kind of the equivalent of that. So grace period is when the dependencies, it's waiting for dependencies. It hasn't started your object because it's waiting for the dependencies. After those arrive, you still kind of get that, I'm waiting for your dependencies, it will block that request. Sort of running out of time here. Professional move there.
Dr. Master.
Oh look, he even had fun little things that I didn't use. There. So you get this. You can pass in different arguments. You can try to get to the point.
So referencing other bean arguments is pretty valuable. Then you skip over it.
So Keith's going to do the rest of the presentation.
It's a good point to point out. This is the argument ref, or even property ref, where you reference another object is how you can do something more complex than just your primitive objects.
Yeah, so you can create like big hierarchies of objects, and you can create free objects and then pass those to a constructor or a setter of some other bean. So a mix and match of objects that are being created in your dependency injection descriptor, the ones that you create and the ones that get injected from other services that exist.
One variant of that that's particularly handy that we use all over the place in VF is lists of references.
Yes, and that's the kind of stuff that I'm trying to get to.
That's how we do a lot of our pluggability. Just implement an interface, and then all of our frameworks will pick it up because now it's part of that reference list.
So this is all of the different things that you can use as values themselves. So that's the part about, okay, you created your bean, cool. But that's it. As that part actually all assumes that you have all your own values, and it walks through. Here's how you do a string. Here's how you do a list. Here's how you do a map. And here's how you do an integer. Blah blah blah. All the stuff that you're going to type in yourself into your file. But since we're here talking about services, well, I want to have my service or my bean have a dependency on other things, other services. So that's where service references are very important. So you can use this reference, and that will actually go out to the registry, and it will get you an instance of this interface. Or it will give you, in this case, a list, and it's what we used to call it a magic list. And it will give you this magic list that is always populated with all of the instances of that service that are available. And as services come and go, they're added and removed from that list transparently in the background. So the way that we use this in our system and for our plugins, sometimes I talked about those points of injection. So those are most of the time lists. So when any request gets to that point in its execution path, then we go and say, okay, we're at this point, fire up all the plugins that want to know when a request comes through at this point, before a search or after a search, to make it very simple. And all of those before search plugins, which we call pre-query plugins, get invoked. And that's a whole list. And so the system just iterates through the list and calls them all using their interface. You can be notified when things come or go from the registry, and that's a reference listener. And so you can actually make a class that's notified that when somebody comes or goes. So rather than have to iterate through all of them, you can get a callback, and you can declare what method you want to be invoked. So you see here bind and unbind. So those are just methods that are expected to be found on your bean when this happens. Question?
So on the reference lists, does it enforce any policies that make you so if there's something removed while you're iterating through said list, it stops it from changing it or you from iterating through it? Or is that left up to the implementer?
That's a really, really good question. So thread safety, do we have concurrent protections against concurrent modification exceptions for the list when we move through? I don't remember. Did we?
No, so I think like iterating over a ref list is supposed to be thread safe. I mean, it would be kind of unhelpful if it wasn't. More often, at least in the time I've been here, where you see threading issues is when someone, throws like an instance member into their Mojo. So you can get called, your class can get called by an arbitrary number of threads via the service interface. So you need to make sure that your class itself is thread safe, and that individual calls are not going to collide with each other or race with each other. That's really the biggest point to mention.
So that was getting an instance. So registering yourself as an instance just uses this service tag. You can have the system automatically export all of your interfaces. So there's some magic there, and it will go and use reflection to find out what interfaces you implement and do all of them, which is a little bit crazy. We typically say, I want to expose myself only on this one interface. Makes a lot more sense that way. So why don't we get to some of the cooler features? Well, this is one that we, Phil and I stopped on earlier, because he didn't know that you could do this, that you could make one bean and give it an ID, and then use this ID ref and actually refer using the bean IDs. The part at the bottom is, again, how to do it in your Pojo, which this would be really, really bad because you now have a dependency on your blueprint container in your Pojo. So one of the fundamental parts of OSGI is the bundle context, because that's the tool at the Java level that's used to look up all these services. And you might find in our code people injecting the bundle context down into their Pojo, and that's another no-no, because now you're doing OSGI things inside your code. Okay, this part. So this is, I'm gonna end here since we're already over time. Configuration admin, which is probably one of the most helpful things, which is that all of the configuration of your system can be handled by the goodness of OSGI. And so this piece here, the snippet that you're seeing, let me zoom in on it. All of these CM tags are used to handle all of the configuration. You can provide default properties. The configuration administration, which those of you guys who are using this stuff, you've seen it, and it gets automatically wired in by the dependency injection system. I'm trying to find a better example here. And it's over. So this is the instance of managed service factory, like what I talked about earlier. So you can declare just by this small amount of blueprint, and Spring looks very, very similar, to create a factory where the system will sort of make an interface that the GUI knows how to read, that allows an administrator to essentially create new instances of your implementation, publish them out on a service interface, foo.bar, and the service properties can be provided by the person, by the administrator at runtime. So they can create as many of these as they want, modify all the configurations all at runtime, and the system can change behavior dynamically.
And they're persistent too.
And they're automatically persisted because that's part of the specification. Yeah, all your configurations. So no longer do you have to worry about how am I going to write this out to disk, how am I going to read it back. Instead, you just throw that all to the container, and it tells you when you have a new configuration, and it tells you when you have an updated configuration or a deleted configuration. Pretty cool. All right, burning questions about OSGI. Any certainly new questions? People that have been working with it for a while, things that you hate about it, you're maybe wondering why things are the way they are? No? All right. Two. These guys won't let me go. Grab a
So if you have an interface registered or if you register an interface with its own interface, like the class that you made, but it implements many other interfaces, is there a way to find that class by getting the parent interface? Like you have a hierarchy of stuff and you register at the lowest level of the subclass and you want to get like a higher level.
So you can discover services based on whatever interface you want, whatever interface you need, and you can register services to any interface. And we saw the thing where it will do the whole chain for you, or you can say, I want to be accessible via this interface and that interface, but nothing else. Once you have, there's no like automatic interpolation or whatever you would call that. It's very declarative. Like you have to say what you want. The services have to say what they provide, and it has to match up. Yes.
It seems like OSGI does a lot. Are there any like performance worries or anything we should look at that OSGI doesn't perform a lot?
So that's a really good question, especially since I gave a long-winded description of how SOA and XML suck. How does this work with inside the JVM? It's surprisingly low latency. There are some good benchmarks that have been done. If you type in like OSGI dependency injection benchmarks, you'll find some cool bar graphs where people have done this stuff. I mean, it's measured in like nanoseconds. The service discovery, the service invocation, all of that. So it really is nice from an architecture perspective because you get all the abstraction that you're looking for at a very, very low cost. I mean, to the point where it's practically just native JVM speed. So it behaves as if you created a POJO and actually used these services as arguments or as setters. What I'm really getting at is that all of the intricacies of service invocations are practically invisible inside the OSGI container. Certainly at the scale that we're at. Good question, though.
There are actually people who are using OSGI in like resource constrained scenarios where they've got people and computers that have tiny amounts of RAM and stuff, and they're able to successfully use it as well. It's kind of neat what they do with it.
So
there was a slide up there on its side.
I mean, so the whole thing can be very, very small. You're reminding me of what is typically one of the very first questions that we get, especially a question that government people always want to know, which is, what does OSGI stand for? Because they can't have an acronym in a document without spelling out what the acronym is. So it's kind of a trick question because it doesn't stand for anything anymore. But does anyone know what it stands for or what it originally stood for?
The eyes for interface?
Yes. So Open Services Gateway Initiative, and it was really targeted at this like Internet of Things. We need a system to run in embedded environments, something to run on your refrigerator and your dishwasher, etc. And there are still a lot of embedded users and use cases for OSGI. It's sort of a happenstance that ended up being so useful in this enterprise realm. And now you see all these huge enterprise integration frameworks all built around something that was meant to run a toaster originally.
Well, Oak was written to run set-top boxes.
Oak? I don't know what.
You don't know what Oak is?
Uh-oh. You know what? I think I just heard a topic for a future meetup.
And Oak was the precursor to Top.
There we go. History of Java as presented by Richard.
Yeah. In fuzzy slippers.
Write that down, put it in the box.
All right, we're 10 minutes over. You guys know where to find me. You guys know where to find me too, because we all work here. It's an easygoing group.